Hi everyone, this video is going to give you a quick walkthrough of Winsteps and the tables in our syntax. So syntax is created in Winsteps. I will show you how to do that in another video. But I want to start out and just show you an example text file. So what this is doing is it is taking all of the data from SPSS or Excel and putting it into its own text file. And it will be a text file. It will not be a Word file. You don't want to open it in Word. Nothing in Winsteps will read that. But really, we just have this top section right here that gives all the information needed for the program to run. Everything below that is our actual information and data. So once we get to this point right here, everything below it is literally your raw data. If you are printing this for any reason, just print the first page. It will be potentially, depending on your data set, hundreds of pages long, and you will not be a happy person. But if you want to print a text file, just print the first page. The very first line is a start command. Don't change it. The second line is your file name of whatever you named this. So this is a BSI scale. That's what the name of our data set was for this example. This just tells Winsteps where to start in the data. Leave that. This is a really nice one. Verify the number of items that you think you put in. So if it says 18 and you thought you put in 20 items, you need to redo your syntax file. Coming down, this is usually a person ID. All of this can be left. This is a really important one to verify as well. So it's picking up that in your data set, you had a 0 to 4 scale. So you had a 5-point scale. You want to make sure that that is true. This is another way that you would pick up missing data. So occasionally I would have 0, 1, 2, 3, 4, 99. Like I did not mean to have 99 in here. That was a missing data thing. This is new score you will not have in most data sets unless you type this in. And this is how I can change these codes. So this allows me to actually change my scoring without literally doing all of that in Excel or SPSS. If you were doing anything with differential item functioning, it tells you what variable that gets split by. These are typically demographics, and we'll come back to that. Going through here, IDLQ equals yes. This is a line that you would also add later into your syntax if you want to be asked to delete items at the start. So if you have a couple items that you wanted to see what happens to the entire model if we remove this, this is a really easy way to do that without having to rerun everything. All that, and then this at end, that is the end command. Don't touch that one. Everything else is a list of the items that you included. So again, if you thought you included 20 and this only says 18, you can go through and make sure. These are typically pulled straight from SPSS or Excel, so whatever you named them is what they are in this syntax. So going back, I want to do just a really quick overview of all of the tables. This is going to be a little bit overwhelming, but by the end of these sessions, you will understand Rosh analysis and know what all of these things mean. But I just want to give you a quick preview on what tables look like. Generally, there is not a right or wrong way to look at different tables, but this is the order that I always look at things in. So we start with dimensionality, then I look at summary statistics for kind of holistic fit, then I look at scale use, item fit, person fit, and I go into looking at the connection between items and persons. And then if I'm doing differential item functioning, we'll go to table 30 with diff. So this is our table 23. This looks at dimensionality, and specifically I'm going to be pulling these three things right here. So I'm going to look at the total variance by the measure. 36% in this case is being explained holistically. I'm also going to be looking at the variance in the first contrast. This is kind of the extra stuff. Is there a second dimension seen? Looking at eigenvalues, which would be the 2.1, and how much is being explained by that second possible dimension at 7.4%. Again, we're going to come back to all of these. This is just a quick high-level overview that you can come back to. Table 3.1 is our summary statistics. There are 3 tables in this, 1, 2, and 3. I'm just going to break those down and we're going to look a little closer. So the first thing to check out is this very first table. We can see that we have 524 people, 18 items, 5 categories. But this first table is only looking at 419 people. These are our non-extreme persons. So we're getting rid of all of the extreme cases and just kind of focusing in on our core people without potential outliers to see how are things working. We have infit and outfit. These are our fit statistics. We have lots of model information over here. We have our person separation. This is a person table. So we have our person separation and reliability right here. That second table down now is our full 524 people. So this is our extreme and non-extreme. And we can kind of go through and check out, does any of this change? It should be pretty close, we would hope, if we don't have extreme outliers that are, influencing the model. We can see right down here at the bottom of this table is our Cronbach's alpha as well. That third table is very, very similar information. It looks almost identical, but now we're looking at all of these things from an item level instead of a person level. Then we move into table 3.2, which is one of my favorites. This is our scale statistics. So here we're looking at our category label. So again, we have a 5-point scale, 0 to 4. We have our observed count. So across all items and all persons, how many zeros did we have? And we can see we had 78% of this sample gave a 0 response. And only 1% of the people in the sample gave a 4 response. So if this is an agreement scale where 4 is strongly agree and 0 is strongly disagree, this sample is highly disagreeable about this construct. So stats ability or stats anxiety, for example, they would be disagreeing considerably that they have stats anxiety, and only 1% is highly endorsing across all people and across all items high stats anxiety. We also have fit statistics for each of our scales or each of our categories. And we have our Andritz threshold, which we'll come back to, but what that's doing is it's changing our 0 to 4 scale into continuous logits. So we now have changed our ordinal data into continuous data. That should blow your mind. We can continue down 3.2 and we've got some more information, but this is my favorite part. So we get our category probability curves, and what these curves are showing is based on ability, how would people be responding, predicted to respond on each category. So people with more ability would be predicted to have more 5s in this case, or more 4s in this case. So we would want, they would be predicted to be more agreeable, and people with less ability would be predicted to be less agreeable. And this is verifying that our 1 to 4 curve makes sense for this data, that we don't have any flips in any of these categories. Table 10 is all about our item statistics. So this goes deeper into all of our item level information. And again, we have fit statistics, infit, outfit, and we have a point measure correlation. So how is each item correlating to the whole? Just a quick note that when you have all of your item names based on your SPSS or Excel, that does not mean that they put BSI 10 in slot 10. In fact, we can see the entry number for the syntax was actually 11. So if you are trying to delete an item using that syntax note, if you want to delete BSI 10, you are deleting 11 in that syntax file. We get the same looking table for 6.1, but now we are looking at persons. And so here we get the same thing of entry number. If you want to delete a person, you would be deleting person 251. And we have fit statistics for each person. So how does each person fit the model? And this is where you would find a lot of your outliers. And of course, our favorite is the item person map, also called the right map, where we're putting items and persons on the same scale. There are lots of different versions of this. In this case, we have just X's instead of the names. I personally like 1.2 the best because it gives you the names and you can kind of retype in here if you want to rename them, which is a little bit nice for publication. And then we have our persons over here. And of course, some of these actually get really complicated if you want to continue and look through the right map options. So just a few overview notes. When you open a table in Winsteps, it was going to open in a text file. Save this file and rename it. So rename it summary statistics, item statistics, scale statistics. And that way you don't have to come back and figure out what was 3.1 again, what was 2.1, what was table 10, all of that, you have it. When you are including tables in a report, you either have to retype them, which is annoying, or you can use a screenshot or snipping tool to keep the formatting. That works for internal reports really nicely, but if you are trying to publish, you have now taken your table and changed it into an image, which journals are not going to like, and so you get to retype them. With item person maps, they are very, very tiny, and it is hard to get the whole item person map on your screen. So if you highlight the entire document text file and go to the top and change the font to either a 7 usually, or if it's a really large right map, you might need to change it to a 5. Then you can see the whole map on the screen. Take your snapshot or snipping tool and you will have the entire thing in an image in one set. Do not change the type of font in the text files ever, 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 ever. These text files are using a special font that has the same height as width. So each character has the same height and width, meaning it's creating a square grid. And that's how we are keeping all, especially the right maps, that's how we are keeping all of the formatting. So just don't do it.